Hi, this is the Tempter podcast where we discuss embedded Linux, IoT development, and anything else we might find interesting. Your hosts today are Kim Raj and Cliff Braid. Hi, Kim. How are you doing?
Hey Cliff, I'm doing great. Thank you.
Good. Great. So today we want to talk about living on Main. So what does that mean, Kim?
Yes, so living on Main is very interesting, and specifically from the philosophy we have been following for your distro for quite a while now, and it can mean many things. Um, it is basically it can be building from main branch, which means that you are consuming something directly from the trunk of a project. And it could also mean that you are using the latest release of a project. So basically you're not forking the project at that release and then doing bug fixes or things of that nature, but rather you're basically going from release to release to release. And um, um, and there's another term for this called rolling release, where you can kind of correlate that to moving from latest release of a component to newer one. So a rolling release model. And I see it like I compare it to that's how nature works, right? So nature doesn't do it where say, okay, I'm done with the earth, let me reset it, install a new earth, right? So it
Mm-hmm.
basically nature every year basically incrementally does and keeps moving, keeps going. So um, I see it in that same way.
Sure. Yeah. So the living on Main, we get that name from the Git main branch, which is where the
Right.
newest development is always done. So we can maybe summarize this by saying this philosophy is basically using the latest or newest of something in a project.
Yes.
Software is what we're talking about. So, okay.
Hmm.
So how does this differ from the way things have traditionally been done?
Yeah. So I think traditionally you have time-based release model where you basically um, do take certain components, test them together, and then you make them work. And there is all kind of testing you do, you know, um, to do like unit testing, integration testing, and all that of nature. And then once you kind of um, do all that, length and breadth of testing, then you're done, and you call that as your stable release. And then in order to do that, basically you test it against known versions of other dependencies or components. And then in order for you to get your component to work, you do selective backporting. So essentially, because remember, the main branches are always moving ahead. So if somebody finds a bug that exists in the previous release which you're using, and you might need that fix. So what do? You basically don't take the next release. Rather, you take that one particular fix and bring it back to that branch. And then you do that for several of your components. It could be one, it could be none in best case, but it could be many, right? And usually it's somewhere in between. And then once you have locked down the versions, made them work together with some selective patching, you call that stable release. And then thereafter, you selectively backport fixes again for the life of that project. You bring in maybe some hotfix or some security fix and things of that nature.
Sure. So it's basically a kind of a very conservative, risk averse strategy. And
Hmm.
we typically see this in like enterprise stacks, large systems where maybe mission critical.
Hmm.
And some examples of this might be like Red Hat Linux. They serve enterprise markets, so
Yeah.
for them, the time based releases is important.
Yeah.
we've been doing a little bit of Zephyr work lately. So comparing that to
Mhm.
traditional microcontroller tools,
Yeah.
the traditional tools from the vendors are very time-based released. You don't have a
Mhm.
lot of visibility into what happens between from one release to another release. They just kind of throw it over the wall, and then you run with that
Mhm. Yeah.
for
Yeah.
a
And I think
while.
the operating systems of the year were
Hmm.
also doing similar release models. So,
Yeah, like Windows and
mhm.
right. Okay. So, what are some of the advantages of living on main?
Yeah. So I think, if you look at this shift left uh, philosophy that I personally believe in as well. So, as you want to find the issues and fix them early in your, in your code flight or your life of your product, or so early it is, the cheaper it is, right? So
Hmm.
it's very easy to fix the problems as they happen, because you notice them relatively quickly, which means that they haven't yet been buried down in other details. So um, fixing them is relatively quicker, and that can save you quite a bit of time, because what happens is there are two things to it. One is that you are in the context, right? So you developed it or did some work on it, so it's still in the context for you, and it's easy for you to really work on it and fix it, rather than you coming down 6 months later when you might have even forgotten about this. So it'll take you some time to ramp up, get to the point, and reproduce the same problem. um, it will be a little slower before, it's like, context switching, right? You pay the price, and so it can basically reduce your cost of fixing them, right? And the one other aspect I really like about it is you don't really accrue any technical debt. You'll find in any work you do, any project you do, any organization, any company you go to, they all talk about technical debt. And you know how do you accrue technical debt, right? So that is the big question. This is how you accrue the technical debt, right? Because you basically uh, stopped something at certain point, and everything else around it, same things are moving ahead, right? So with time you are building that technical debt indirectly.
Hmm. Yeah, yeah. It's all about staying nimble and fast. And
Hmm.
if you accrue technical debt, pretty soon you get to the point where all you do is service that debt.
Hmm.
It's kind of like financial debt. So you
Yep.
have to try to avoid that scenario,
Yeah.
and we feel this is one of the ways you can do that.
Hmm.
The other comparison I like to make is to manufacturing. If you have an assembly line or cell based manufacturing or whatever you do, and there's a problem that gets introduced into that process,
Hmm.
and you can find it quickly, it's much cheaper to fix then than it is when there's 2,000 cars out on
Yeah.
the lot that, or even out in customers' hands that need to be recalled.
Hmm. Hmm.
So it's the same with software, maybe not to the same degree, but
Yeah.
to get somebody's attention when they've moved on to something else is much harder than when they're actively working on
Yeah.
the version that you're actually using. So,
Yeah. And I mean, you should also look at, because they are also, if you are dependent on other teams, they are also having their cycles of development. So it's also disruptive at certain point, for you or for the team to give you a specific timeline to fix your problem. And they will be conservatively giving you a longer timeline, because, obviously they have to like switch from whatever they're doing back to servicing your needs.
mhm.
Um, and what happens is, always remember, it's not linear, right? As time goes by, it is exponential. So the technical that you're accruing is actually getting bigger and bigger and bigger by day.
So you're charged interest on your technical debt, right?
Yeah, compound interest. Yeah.
Compounding interest, yeah. So,
Yes.
okay. Whereas if you invest in processes that go the other way, those also compound, and
Yeah.
it makes your development accelerate. So it can go the other way as well.
Yeah.
So what are some examples of projects that or software that works out well to apply this philosophy?
Yeah. So I think, speaking of from history, Gen 2 Linux distribution, right? They were source-based distribution. So that was kind of a rolling release model. They basically would build the release of the day, right? But then I think there has been like Arch Linux, which is my distribution of choice when it comes to using Linux, which is basically a binary distro. But they basically are doing exactly this, which we just talked about, where whenever there is a new release, they come take that release of that particular component and integrate that into latest Arch, and then as all the tests, everything pass, they push the feed, and it's available to you as soon as they are pushed, right? So, and they also have various ways to kind of make it easy for you to consume that. Like they have testing feeds, and testing feeds are if you're like interested in living on the edge, you can use that, or you can wait for it to appear in the main feed, which might be like a week later or something, and it'll be pretty stable. And I think Yo distro, we basically maintain it, use it. It follows a similar philosophy. We are basically using a composite of Yocto project layers, and we always stay on the main branches of the layers we use, and then layers are providing the latest versions of the components that they provide. So what we do in Yo is very similar to the two things that we mentioned earlier, where what are the different ways of living on main, is that we basically on the main of certain repositories, and then there are like the latest releases of the components those layers are providing. So it's a combination of those. And Gitea, I guess. I think you are very familiar with Gitea, because we host that for the back Git services. So what are some of your favorite projects in there?
Yeah, Gitea is great. It's a Git hosting platform, very similar to GitHub or GitLab.
Mm-hmm.
And I've been hosting my own instance for a number of years.
Mm-hmm.
And every time a new release comes out, I immediately update, and I don't even think about it. So my update process does back up the database. So if something goes wrong, I can easily roll back. But I've never had to do that. I've been through dozens and dozens of updates, and it just keeps working. The other project we've been using is Zephyr for microcontroller development. It's an RTOS, and in our development, we simply track the main branch of the main Zephyr repo, and every week we pull in the latest main branch. Sometimes we have to tweak a few things, but it's usually a very quick process. It's been a great experience. And I think one thing these two projects have is good testing. So Zephyr has extensive testing, and I've never looked into it, but Gitea must as well, to maintain the level of quality that they do.
Right.
So I feel like the philosophy of testing has changed from the traditional software where you have a QA department that does a bunch of manual tests. It's a big deal, to more of a CI-driven process where you check your code in, everything runs automatically, you get a green light, boom, you release it, and you basically remove that manual testing step, which was the traditional way that you try to bring quality into software.
Right. Yeah. And I think one of the examples how it really makes you effective. I could cite one recent example in Yo distro development where we had basically updated the Freescale layer to their latest BSP, and then our bills, nightly bills, basically caught that we couldn't start the Western UI, and so Western wouldn't start, right? So essentially, that's the nature of the problem. But then the corpus for you to look at in last 24 hours is very small, and
Hmm.
you could easily pinpoint the problem, within 5 minutes. So I think we'll provide this link in the show notes, but you can go through. We basically reported the problem, and the developer was already tuned in, as we talked about. So the fix was provided within a day, and the next nightly we had it fixed.
Yeah, that's amazing.
Hmm.
So what are some objections to or common perceived problems with living on Maine?
I think there are valid concerns, and those are about the dependencies aren't well understood.
Hmm.
And I'm not here talking about build time dependencies, but there are runtime dependencies like API contracts, servicing, layers above or below. And I think um, the real reason is that you don't want to provide something that is tested just within itself, but you want to kind of enhance a little bit of testing around, the APIs and how it interacts with the rest of the system. And I think that is what brings in a lot of, disbelief, so to speak, if I have to say that, into this kind of model, because people are scared of putting in something and then saying that, hey, it may destabilize the whole system, which is true
Hmm.
assertion. However, if you look at the process, so I think process is the most important aspect of it. And you basically have to have, if you have a good CI, for example, and then you write good amount of tests, not only to test your unit, which you did, but also do some level of mocking or that sort of testing, which you can get some idea of how the APIs are behaving, for example, and make them automated. So you can basically run them, whenever you push a change, all your APIs are tested, for example, right? Then you can be very confident of saying that, hey, by the way, this release is backward compatible with all my APIs, and the new APIs are new, right? So you can be very confident of pushing that change out. And I think Linux has been always a prime target for such a method, because everything is very componentized in Linux, right? So if you look at it, it's every component, like bash shell, everything is a separate component. So you can do this very effectively in a Linux based system.
Sure.
But I think, to my mind, the tooling, I mean the testing, for example, the view of CI, the infrastructure for that is very critical, and you'll spend some time servicing those needs, because CI systems will go down or will need some updates, or all that will come in. But I think that's just part of the game.
Sure. Yeah, and I appreciate the thought that you have to do more than unit tests. You have to have
Hmm.
what I call integration tests or,
Yeah.
or system tests.
Yeah.
And the neat thing is that those are pretty easy to spin up now with Docker.
True.
And like if you look at the NATS project in their testing,
Hmm.
they spin up a NAT server in every test. You can do that. You can spin up a database in every test.
Mm.
So,
Yes.
as we tend towards more lightweight building blocks, it's getting easier and easier to do
Hmm.
full stack testing very
Yeah.
quickly and efficiently. So,
Right. And I think the other aspect of it is also important, which is more like a mindset. And you have to participate. right? So you have to have that mindset where you are a participant in what you're consuming, not just a consumer mindset. So if you have that change of thought, and then you are in, and you are in for big benefits of it as well. So a lot of times, people say that, hey, I know nothing about this. How can I be a participant? I am a consumer, but that's not true, because I always say that, code contribution is the last thing that you do to a project, right? There are many ways you participate in a project, and it could just be, um, I just say that you're on GitHub, and somebody has opened an issue which you are experiencing too. You just say +1, which basically, tells the developer saying that, hey, this issue is hitting many people, so it may be prioritized, for example. There you go, you have participated in the project. So you could basically maybe document your use case, right? And you can just say, hey, this was the problem, and you can just describe the problem on their channels, be it mailing list or GitHub issue, GitLab, whatever the community uses. You have participated. So there are many different ways, right? You could spread the word. If a new release came out, you can send a tweet, or you can send a LinkedIn post or something like that. You have participated. So there are so many different ways to participate in that project. And what it does is it kind of like also gives you that confidence of knowing what the project has released. You are way more confident of consuming it in that way.
Yeah, I think it's kind of a little bit of a tangent, but as a consumer of open source software for building products, it's a good idea to have some sense for how these products are developed, who's
Hmm.
behind them, are they doing okay, is it
Hmm.
sustainable? Because and the best way you can get a sense for this is being a participant in the project, and then you also learn very valuable things about how to use the project.
Hmm.
And if you structure your development right, it doesn't have to be a lot of effort. If you set up good build systems, you can
Hmm.
pull in the latest stuff, give it a try. It doesn't have to take a lot of time.
Hmm.
And and then once you're ready to update for your release, then you're all set to go. It's not a
Yeah.
big bucket of work that needs to be done.
Yeah. Yeah. And I think a lot of open source projects, I know they are always, um, you know, more testing is always good, right? So
Yes.
if you go and pull their latest head, on the trunk, and then give it a shot, just compile it, and then try to use it. Maybe you're not just kind of using it in a production scenario yet, but just give it a shot on the sideline and report back saying that, hey, it broke or whatever, right? And that's also participation, as we were talking a few minutes ago. But it's also basically helping the project, as to your point, that they're getting timely feedback on the project that they really need. Otherwise, that would basically be coming in through some other channels, and um, you might have to wait until that, or so you are basically then at the behest of someone else reporting it, someone else finding it for you. But in this case, you are a participant.
Yeah. So a great way to try this philosophy is to use Arch Linux.
Yeah.
And a lot of people I tell people I run Arch Linux, and they like raise their eyebrows, and
Mm.
they I've even gotten comments about like things breaking all the time,
Hmm.
and a lot of people are very dubious about Arch Linux, but we've been running it for years. It works great, very few problems, and I
Hmm.
feel like the benefits way outstrip any negatives or problems. So give it a try. It's a great
Yeah.
way to live out this philosophy. If
Hmm.
you're an application developer and you develop on Arch, you'll have a continual feed of the latest stuff automatically coming in to your
Yeah.
distro. So if you want to practice the living on main philosophy, in
Mhm.
application development, then Arch Linux is a good platform to
Yeah.
do this. And you can also have your, your stable production build, set up with Docker components, to lock
Yeah.
things down. But
Mhm.
um,
True. Yeah. I think, I've been using Arch as well for many, many years. My install has been running since 2016 or something. And
yeah,
I'm even like, a little embarrassed to tell people. But yeah, that's how old my machine is, one of the ones. And,
yeah,
but I've been updating it ever since, and I've had few issues that were self-induced. Um, I've the recent problem I had was my NVIDIA driver went out of sync because they had NVIDIA utils and then NVIDIA driver, and then for a moment they were kind of out of sync. So I said, oh, I can't update because of this whatever. I uninstall NVIDIA driver, and I didn't reboot anything. I went back, a day later, and I reinstalled NVIDIA driver. Things were fixed,
yeah,
right? This was me being so impatient. But generally, a few hours, if you're looking for like a week worth of update, you will never see these kind of issues. I
right.
mean, there is a chance of you getting in the middle of it sometime, but it happens very, very rarely.
Yeah. And I would say the problems I hear about from my associates running Ubuntu, they run into at least as many problems as I do. So,
Yeah,
I don't feel like it's,
yeah, yeah. I
um,
think it's really good, and I think if you are working on something like embedded systems, try your distro,
sure. Yeah, absolutely.
and
Yeah.
that
If you,
also we follow the same methodology. So
mhm. So that's our thoughts on living on Maine. If you have any feedback, please let us know. You can email us or reach out to us on the Tempter Community Discourse site or any of the other ways. Feel free to let us know what you think. Until next time,
bye
thank
bye.
you.